Welcome back, and today we're diving into one of the most profound questions humanity has ever dared to ask. Are we alone in the Milky Way? Our galaxy, the Milky Way, stretches across roughly 100,000 light years and contains somewhere between 200 and 400 billion stars, and around each of those stars there could be planets, worlds we've never seen, atmospheres we've never breathed, and perhaps life we've never imagined. For most of human history, this question lived in the realm of philosophy and fiction. But today it sits at the very heart of modern science, and the search is more serious, more funded, and more exciting than it has ever been. Let's start with what we know. Since the early 1990s, astronomers have confirmed the existence of over 5,500 exoplanets, planets orbiting stars other than our Sun, and that number grows every single year. The Kepler Space Telescope alone identified over 2,600 confirmed exoplanets during its mission, revolutionizing our understanding of just how common planets actually are. Before Kepler, we didn't know if planets were rare exceptions or the universal rule. Now we know. Almost every star you see in the night sky likely has at least one planet orbiting it. That is staggering. That means the Milky Way could host hundreds of billions of planets, and among them, scientists estimate that tens of billions could be rocky, Earth-sized worlds sitting inside the habitable zone of their star, that Goldilocks region where temperatures are just right for liquid water to exist on the surface, and where liquid water, as far as we know, is the single most important ingredient for life as we understand it. Now, let's talk about the planets we've already identified as strong candidates in the search for life. One of the most talked about is Proxima Centauri b, a planet orbiting Proxima Centauri, the closest star to our Sun at just 4.2 light-years away. It sits in the habitable zone, it's roughly Earth-sized, and the fact that it's so close makes it one of the most studied exoplanets in history. But there's a catch. Proxima Centauri is a red dwarf star, and red dwarfs are known for their intense stellar flares, bursts of radiation that could strip away an atmosphere and make the surface of any nearby planet incredibly hostile to life. Does that mean life is impossible there? Not necessarily. Some scientists argue that life could evolve underground, or in deep oceans shielded from radiation, or that a strong magnetic field could protect the planet's atmosphere. We simply don't know yet, and that uncertainty is exactly what drives scientists forward. Then there's the TRAPPIST-1 system, perhaps the most exciting discovery in exoplanet science in the last decade. Located about 40 light-years away, TRAPPIST-1 is another red dwarf star, but what makes it extraordinary is that it hosts 7 known Earth-sized planets, and 3 of them, TRAPPIST-1e, F, and G, sit comfortably within the habitable zone. 3 potentially habitable worlds in a single star system. The James Webb Space Telescope, which launched in December 2021 and began science operations in 2022, has already started studying the TRAPPIST-1 planets, looking for signs of atmospheres, measuring temperature distributions, and searching for molecular signatures that could hint at biological processes. Early results on TRAPPIST-1b and 1c suggested those 2 inner planets likely lack thick atmospheres But the habitable zone planets are still being analyzed, and the scientific community is holding its breath. Moving further out in our search, we have Kepler 442b, a planet about 1,200 light-years away that scores remarkably high on what scientists call the Earth Similarity Index, a scale from 0 to 1, where Earth scores a perfect 1, and Kepler 442b scores around 0.84, making it one of the most Earth-like planets we've found so far. It receives a comfortable amount of energy from its star, its size is close to Earth's, and its estimated surface conditions could theoretically support liquid water. We haven't been able to study its atmosphere yet, but it sits on the short list of worlds that keep astrobiologists up at night with excitement. There's also K218b, a planet about 120 light-years away that made headlines in 2023 when researchers using the James Webb Space Telescope detected potential signs of a molecule called dimethyl sulfide in its atmosphere, a molecule that on Earth is only produced by living organisms, specifically marine phytoplankton. Now, scientists were careful, and still are, to stress that this detection is tentative, that other chemical processes could theoretically produce the same signal, and that more data is needed before any extraordinary claims can be made. But the fact that we are now at a point in history where we can look at a planet 120 light-years away and ask whether the chemistry in its atmosphere could be biological, that is an extraordinary milestone in the history of science. And we shouldn't forget our own solar system. When we talk about the search for life in the Milky Way, Mars was once a warm, wet world with a thicker atmosphere and flowing rivers. An ancient microbial life may have existed there billions of years ago. NASA's Perseverance rover is currently drilling into Martian rocks and collecting samples that will eventually be returned to Earth for analysis, and those samples could hold fossilized evidence of ancient life. Europa, a moon of Jupiter, has a global liquid water ocean beneath its icy crust, kept warm by the gravitational tidal forces of Jupiter, and NASA's Europa Clipper mission, launched in 2024, is on its way to study this ocean world in detail. Enceladus, a moon of Saturn, is actively venting water vapor and organic molecules into space through geysers, and its subsurface ocean has been confirmed to contain hydrogen, carbon dioxide, and methane, the basic chemical building blocks that here on Earth are associated with hydrothermal vent ecosystems that support life without any sunlight at all. The search for life in the Milky Way is not just about finding creatures walking on alien continents. It's about understanding whether the chemistry of life is a universal phenomenon or miraculous accident that happened only once here on our small blue planet. The Drake equation, first proposed by astronomer Frank Drake in 1961, attempts to estimate the number of communicating civilizations in our galaxy by multiplying together factors like the rate of star formation, the fraction of stars with planets, the fraction of those planets that develop life, and the fraction that develop intelligent, communicating civilizations. Depending on how optimistic or pessimistic you are with each variable, you can get answers ranging from tens of thousands of civilizations to just one, us. The Fermi paradox then asks the uncomfortable follow-up question. If the galaxy is so big and so old, And if the conditions for life seem so common, then where is everybody? Where are the signals, the megastructures, the visitors, the radio transmissions? That silence is either deeply meaningful or simply a reflection of how vast and young our listening efforts really are. The SETI Institute has been scanning the skies for artificial radio signals for decades, and Breakthrough Listen launched in 2015 with $100 million in funding as the most comprehensive SETI program in history, monitoring millions of star systems across multiple wavelengths. So far, nothing confirmed. But absence of evidence is not evidence of absence, and we've barely scratched the surface of the search space. The tools we have now, the James Webb Space Telescope, next-generation ground-based observatories, like the extremely large telescope currently being built in Chile, future space missions, advances in artificial intelligence for analyzing astronomical data. All of these are giving us capabilities that were unimaginable just 20 years ago. We are living in the golden age of exoplanet science and astrobiology, and the question is no longer whether we will find the signs of life beyond Earth, but when. The universe is 13.8 billion years old. The Milky Way alone contains hundreds of billions of stars. The conditions for life appear to be widespread, and we, a species that only invented the telescope 400 years ago, have already identified thousands of other worlds and are now reading the chemical signatures of their atmospheres from billions of kilometers away. Whatever the answer turns out to be, whether we discover microbial life on Europa, detect a biosignature on a distant exoplanet, or one day receive an unmistakable signal from another civilization, the search itself is one of the greatest scientific endeavors in human history. And every new planet we find, every atmosphere we analyze, every mission we launch, brings us one step closer to answering the oldest question we have ever asked. Are we alone? The voice you selected does not support this language. Please click the upper right corner to switch to another voice.